All right, so this is the video for 3b. What we need to do is to show that this formula entails G and that this formula and this formula each don't entail G. So to do that, it's fairly straightforward. In this case, we just need to show that every row in the truth table that makes this true makes G true as well. So we can start by filling in the values here. Usual truth table stuff. Flip the values. I'll just copy out the values for G here. And we can see that there's only one row in the truth table that makes this formula true. And on that row, G is also true. And so that means that every row that makes G true also makes, every row that makes this true also makes G true. So this formula entails G. There weren't really too many problems with this question, as in like a 3b in general. The only issue that sometimes came up was that some people didn't fill in the truth tables properly. We don't expect you to fill in the values of the atomic sentences here, but we do expect you to fill in the values of all of the connectives. So if you, for example, didn't fill in these values for the conditional, you'd get deducted some marks. Okay, so this shows that this entails G. For this, we need to show that it doesn't entail G. I'll fill in the values, flipping those of F. Using G and not F, we can find the values for the whole formula. I'll fill in the values for G again, just to make things clear. And we can see that there are two rows in this truth table that make this formula true, but that make G false. So these are counterexamples to the claim that this formula entails G. So it doesn't entail G. And the same thing happens with this case. In fact, these two formulas actually are equivalent in logic, or in truth functional logic at least. So we'll fill in the values, usual truth table stuff, flip them. And so, as you can see, they're equivalent, which means that the bottom two rows, again, show that this formula does not entail G. And that is question 3b.